Hey everybody, welcome to the video on piecewise linear functions. So, before we get into that, let's talk about a few things that we've talked about before. Let's review. As we all know, we have a big cumulative exam coming up, so let's review. What's a domain? A set of all x values belonging to a function. What's a range? Same thing. It's a y value. A set of all y values belonging to a function. Okay, so what's the domain of this line in interval notation? Well, the domain is the x values, right? So we know it starts from there and ends right there. X equals -1 to x equals -2. So we're including x equals -1, but we're excluding 2. And then another way I can write that is to talk about the x values, all right? I know my x values will always be less, or they'll always be greater, sorry. The x values will always be greater than -1, you see? But they'll be less than 2, all right? I'm describing the region as to where my x values will be, okay? It's my domain. My range is also the same as my domain. So my lowest point here is -1, and my highest point is 2. So it's my lowest point, -1, my highest point is 2, and I'm excluding 2. So my domain is pretty much the same interval as my range. All right? So notice some things. If I have my square bracket, it means the same as the including, all right? Greater than or less than or equal to, all right? That's what it means. So including notation. And if I have my curly bracket and just a simple less than symbol or greater than symbol if we needed, this is excluding notation. All right. So let's get to it now. A piecewise function is a function that is broken into different segments. So I have one right here. This one in particular is called a step function. One of the simplest models of a piecewise function, one of the simplest piecewise functions to deal with. So basically, what we have is a different output for a different set of intervals, all right? This function has multiple domains, all right? Has multiple outputs for different intervals in the domain, in the overall domain, all right? So how would I write this function definition? Okay, what I need to know is the output of a function at a particular domain. So I start from the beginning, the far left. So I know this, okay, if this domain runs from -7 to, so am I including -7? Yes, I am. So I know my x values are all greater than -7, but they'll all be less than -3. All right, then what's the output of the function in this domain? It's +6. All right, let me change color for the next one. So I know my domain here starts from -3. Yeah, -3. So my x values, I'm including -3. Including -3, my x values over here start at this point and end at x equals 2. So my x values will always be less than 2. All right? Now, for the last part, oh, sorry, what's the output? What's the function output in this interval? That's 3. Now the last part, what we have, domain start at 2, so my x value will always be greater than or equal to 2, but it will always be less than 6 for this region. So you see, and these basically are the same thing as the brackets and square and the parentheses. So what's the function value? What's the output at that point? We have a -3. All right. So there's our function definition. There's our function definition. So I'm going to copy here for convenience. Now a function definition. Okay, let's find the particular values. Like, let's try to find what's the value of my function at a particular input value. So like, for example, here I have f of -6. How do I find the value of my function at -6? So especially if my function is piecewise, I have to go to the region where -6 exists. All right. So which of these regions would -6 exist? Does -6 exist between 2 and 6? I don't think so. Does it exist between -3 and -2? I don't think so. But I know it exists between -7 and -3. All right. If I look at my graph again, -7 and -3, I have -6 right there. So what's the value of my function there? Well, I have a step function, so that's easy. It's 6. Okay. Now, next. What about 4? Where does 4 exist? 4 exists in this region. It doesn't exist in this one. +4 doesn't exist here. It exists it's in between 2 and +6. So the value of my function at that point is -3. What about -2? Yeah? Where does -2 exist? Well, does it exist between +2 and 6? I don't think so. It's not in that region. Does it exist between -7 and -3? No, it exists between -3 and +2. Okay, so what's the value? It's 3. And then 0, where does 0 exist? 0 exists between -3 and +2 as well. So it's 0. And oops, it's not 0, it's 3. It's just 3. So that's how we do it. Now let's try a more complex example. This example was very easy. All right, step functions are the easiest piecewise functions to deal with because everything is just direct. What if we have multiple functions? Yeah. What if our function definition looks like this? All right, let's start by graphing it. Yeah, let's start by graphing it. So this is our function. All right, let's graph it. Now the easiest way to graph a piecewise function is to graph the endpoints. All right, the endpoints of the region. So I'm going to use different colors for different regions. Okay, so if I have this, let's start with this guy here. All right, I know my function from -7 to -1 follows this function. So that means I know 2 lines makes a point, right? So I know my x value will be -7. So at least one x value will be -7. All right? And another x value will be -1. Okay. So now I need to know the y values at those points. So 2x, let me start with at -7. All right? So first, f f of x, so that's the same thing as a y value, f of x at -7, so I have 2x plus 2, and f of -7 is going to be 2 minus 7 plus 2. And that's going to be -12. If you calculate this, so this is going to be -14 plus 2 is going to be -12. So I should go a little bit lower. So this is going to be 10 minus 10 minus 11 minus 12. So there, I have my first point. Nice. What about a -1? What do I have? Let's see, f of -1. What do I have? So it's going to be 2, -1, all right, plus 2, minus 2, plus 2, 0. So I know I have 0. My y value is equal to 0. So I'm right there. All right, now I have to be careful. Am I including or excluding? So at -1, I'm excluding. So I need an open dot. And boom, 2 points make a line. So I've graphed my first point of my piecewise function. Wow, that's it. That's not too bad, right? Not too bad. So now I can carry on. Let me change colors. Let me do this. Let me do this one here now. All right. So my function f of x is x plus 7. So again, get the endpoints. Get the endpoints. Because 2 points make a line. So I know I have at x equals -1. What's my output value? So I know this is going to be -1 plus 7, which is just going to be 6. So I go to x equals -1, all right? And then I go to positives, and I know it's 6. So I'm right here. Am I including? Yes, I'm including. All right? Oh, okay. Yes. So I try the other endpoint now. What if f of 1? F of 1 is going to be equal to 1 plus 7. It's going to be equal to 8. All right? So f of 1. So 1 plus 7, 8. Okay. So my point here is 1, 8. Now I go to x equals 1, and then y equals 8. So 2 points make a line. Am I including or excluding? I'm excluding the 1 there. So boom. Oh, this is disturbing me. Yeah, I'm excluding right there. Now let's just do the last one. Let's see the last one. This one here. So same thing I've been doing. Let's see. F of x is going to be equal to 3x minus 4. Yeah? So now let's do this. So we got, let's use the endpoints again. F of 1 is equal to 3, 1 minus 4, which is going to be equal to it's going to be just 3 minus 4. It's going to be, so we're going to have f of 1 is going to be equal to minus 1. So our point here is going to be 1 minus 1. Yeah? So, and am I including? Yes, I am. So 0.1 minus 1. I'm right there, and I'm including. Yeah. Let's check our final point. 0.7. F of x is equal to 3, 7. Oopsie. There's wrong notation. F of 7 will be equal to 3x. 3, 7 minus 4. It's going to be 21 minus 4. Oh no. This is going to be 17. So that's somewhere up here, so I'm on, my point here is 7. So if my point is 17, so my point here is 17. So x equals 7. And then if I push this to the side a little bit, make it smaller, just put that there. 17 is probably somewhere there. It's very far, my axe is not big enough. So that's 17. So I go x equals 7. All right. And am I including? I'm including that point. So, okay, then I just join the two lines. And voila. Oh, I see I'm a bit low. 17, I'll put that right there. So just approximately in that region, all right? Just because I didn't want to go too high. So on 17 is, our point 17 is over there. And that's how you graph piecewise functions. There are other ways to do this, but this is the fastest way to do it. Just get the endpoints and plug them into your function. Get your 2 points, and two points make a line. Make sure they're including and excluding, all right? So there. Now, yeah, we can find the same way we did for step function. We can find function values, all right? Function outputs. So what if I want to know what f of 6 is? So f of 6, I go to the definition. I go to the region where f of 6 exists, or f of positive 6 exists. Here, I see it exists only here. So I see the function is 3. So it's 3x minus 4. So f of 6 is going to be g minus 4. That's 18. 18 minus 4 is what? 12. And then here, f of 0. Where does 0 exist? It exists between these two here, -1 and +1. So my function is just going to be 0 plus 7. I'm subbing the 0 for x. It's going to be 7. Then here, where does +7 exist? Well, let's make this -7 so we can use the other guy. Yeah. So f of -7 exists in this function here. So I can, let's see, I can use this function to get the value. F of -7, it's getting the output. It's going to be -14 plus 2, which is going to be -12. All right. And that's really how we're going to work with piecewise functions in this class. I hope this video was insightful. I hope it was helpful. Yeah. Can't wait to see all of you in class. All right. See ya. Bye.